same as that too. So, no, it doesn't. I wish it did though. Okay, so let's get from my slope here. Can I pick a person at random? That's going to be Emma. Can you please take the derivative of 3 to the x? Go ahead. That's all there is to slope. That's all there is. Now the problem is for this is that you need to remember another rule. Okay, that's the only thing for the derivatives here. Okay, what's my let's try this again here. What? Hold on a second, let's try this again here. That's what f prime of x is equal to. My slope is going to be what? My slope is going to be f prime of 2, right? So it's going to be ln 3 times 3 squared. So it's going to be 9 times ln 3. I'm going to leave it like this for right now, but if you want to call it 9.8875, I'm not going to yell at you for right now. Okay? Are we all okay about that? The derivative is going to be f prime of x. Sorry. The derivative is going to be f prime of 2 for that. Okay? How do I get my y value? Somebody knew that I haven't talked to you today. Go ahead. How do you get my y value? Good. Y is going to be f of 2, which is going to be 3 squared, which is going to equal 9. So my equation is going to be, I have m is equal to 9 ln 3. I have my x is 2. I have my y is equal to 9. So I'm just going to solve y equals mx plus b. 9 equals 9 ln 3 times 2 plus b. And if you have a decimal for that, that's fine. I just use exact values because I like them better. So it's going to be 9 minus 18 ln 3 equals b. So my equation is y equals 9 times ln 3 plus 9 minus 18 ln 3x. Can we get decimals? So somebody do with decimals? I do. Give me the number for decimals.
Y equals 9.8875 minus 10.
Okay, does that look better for people? Okay. I like exact values. Michael, go ahead. Which one? This line here or this line here? Which one? This one here? Because just think y equals mx plus b, right? Like that's the equation of a line is. So just y equals mx plus b. Oh, because right up here, right? F of 2, like so you sub your x is equal to 2, right? So you sub it back into the original equation. So it's 3 squared, so it equals 9. That's your slope would be. Your slope would be 9.88, right? But just if you look into your regular equation, if x is equal to, into the first one, because it's, the original. I was going to do a big word problem. I'm going to leave that till tomorrow. I'm going to talk about more derivatives here to finish up today. Today I'm just going to do derivatives. Tomorrow we'll deal with word problems, okay?
For the last lesson.
You want to make me cry here, yes.
Well, because I only have like 2 pages left in my book.
You're in luck.
I mean, we got to finish this.
You're in luck. How many pages is that book?
200. Yeah.
Okay, and I bet at the end of the year you said, well, Mr. South, I'm going to need like 50 pages. The only person you used 50 was probably Noah, would be the only person.
15 tops.
No, he does like a 12-page assignment in half a page. I don't know how he does it. But I'm just not to embarrass you in front of the whole class, but I love it when you highlight your answers in pink or purple. That really makes my day. So I don't have to go looking for them. Okay. No, it does. It's a pleasure actually. Examples. Implicit differentiation for logarithms.
No, do like margin zero. Like if you didn't watch it, you did that.
No, sure.
So if you didn't do that, you didn't have it. Then you didn't put access in on the dot instead of dot.
Just a new note or just like?
Just a continuation, you can do it.
And if you didn't base it like that, yeah. And that's why all my solutions are like that, because it's the reason. It's very
Okay, if I give you y equals ln x, in logarithmic form, what does y equals ln x mean the same as? What does ln mean the same as? Log base. Yeah. So this is the same as y equals log base e to the x, which is good. Now here's the aha moment. What is this as exponential form? Somebody write that in exponential form for me, please. Go ahead, Austin. X equals e to, I'm going to solve e to the y equals x. What's the right answer? Okay, we're going to say we will take the derivative of this. Using implicit differentiation. This is probably, since this is the second last day, this is the final and the most powerful differentiation rule you will learn in this course. Because whenever you have a teacher in university that tries to be mean to you like I have been, you can show them this way and it'll make your solutions really nice. I'm going to show you why right now. Okay, e to the y equals x. Let's do some differentiation. What's the derivative of e to the y, please? No, not y to the y. Per quad e to the y? I'm just taking the derivative of both sides, right? So let's start with the left-hand side. What's the derivative of e to the y?
Ln e, which is 1 times e to the y times d by dx.
Okay, can somebody, Derek is correct. Can somebody explain to me where the dy by dx came from? Because this is really important. Yeah, go ahead. Yeah, the derivative of the y just changed to dy by dx. Very good. Okay, so feeling okay about that before I continue? What's the derivative of x equal to? This isn't a trick. 1. Good. Okay, let's isolate dy over dx. Go ahead. Now this is the magic step. E to the negative y become 1 over ey. Now, what is e to the y equal to? Cool. Cool. So the what that we said is, what this actually tells me, therefore, so what I just said is the derivative of ln x is just 1 over x. That's what we proved. Okay, right? The derivative, because that's what y initial was ln x. So the derivative of ln x is 1 over x. This is helpful in complicated derivatives. I'm going to show you right now why this is helpful. Because we could do this the complicated way, and we can do it the easy way. I'm going to show you the easy way. Are you ready? I'm going to think of the worst derivative I can think of. I'm going to show you how you can solve it with logarithms very easily. Okay, and this is going to make your life easier. You're probably going to hate me again, but there's only 2 days left in class, so I don't care. That came out wrong. Okay, right? That came out wrong. Oh, you're right. What example are we up to? 4? 3? 4?
I'm going to take calculus again. Nah, I'm just going to try really hard. Oh, let me get that tool.
Okay, now, this is a hard derivative. I'm not gonna beat around the bush. Without logarithms, you could do this one. And I gave this to you on your derivative test, and it took you a long time. Similar to it. It was similar to it. Right? There'd be a quotient, sorry, a product in the top and then a quotient all together. Like this is a big derivative if you think back. Okay, you guys can do it, I'm confident in you. Okay, I'm gonna show you how to do it with logarithms, and involves no brain power. Okay? I'm gonna let Michael finish writing it, and then I'll start talking about it, and other people are still writing too. Sorry, Michael, just to be out there. Me too. I was very happy you didn't send reminders today, though. That's made me quite satisfied. All right, are you ready? Almost? Okay, I will go through step one, and then you guys can tell me how to simplify. Step one is just going to be ln of everything. So I'm going to say ln y. That is a giant bracket. But that's okay, we can deal with that. Okay, now I'm going to pick on someone at random. Actually, they're going to volunteer their answers. Now, just remember, Chris Lee is not here today, so I need everyone to be brave and raise their hands. If you have a ln of a triple thing like that, let's use our power rule, or use your logarithmic rules. How do you deal with a ln of three things? What can you change that into? What log rules do you have, or ln rules? What are the log rules? Like the log of x times y. What's log of x times y equal to? Yeah?
Can you change it so that like you subtract?
Yeah. We're going to add and subtract. These two things are going to be very good. So Hannah, these two things are going to be added because they're in the numerator, and that's going to be subtracted because something's wrong. Okay? So I'm going to change this to ln y equals ln x to the 4 plus 1 plus ln of x plus 2 to the 1/2 minus, I'm running out of room. I'm going to go to two boards here in a sec, okay? So I just want to make sure I haven't lost anybody yet, because this is the fundamental part of these types of questions here. Alistair, how are we doing? You okay with algebraically how I got from step 2 to step 3 there? Because the algebra step is what I want. We'll get to the calculus part in a second here, okay? What's that? Yeah, so all I did for this was, remember, ln is like logarithms, right? So when you take the logarithms of two things multiplied, I can write that as pluses. Like split them apart in terms of pluses. And the same thing when you divide, and split them apart and subtract. Right? I'm just using the log. Sorry guys, I can't hear. See, we're just using our log rules, but remember the ln is log base e. So we're doing the same thing as our log rules there. Yeah, it turns to minus because that's divided, right? The you know what I mean? That 2x squared plus 2x plus 1 is divided. Okay, there's one other log rule I'm going to use here before I continue. What's the only thing that's sort of sticking out there that looks a little bit ugly? There's only one part of this equation. It's 1 and 1/2, very good. How do you get rid of 1 and 1/2?
Square everything.
I didn't mean to say that. Did I make that noise? I didn't mean to. I heard what Derek said. I'm going to take Derek's idea better. Now this idea is much, much better than squaring everything, okay, because you would have had to FOIL, yeah, don't do it, okay, don't square everything. Yes, Michael, stop, I don't.
That could be a negative 1/2.
No, because it wasn't in the denominator, right? Excuse me, it wasn't in the denominator. This, we haven't taken any derivatives yet, we're just using our log rules. We've done no derivatives yet.
Oh, you can do that.
Yeah, well, I'm going to show you why I want to avoid doing derivatives, and this is going to work out quite nicely, okay? So, the way you take the derivative of ln is you do 1 over whatever you're taking the derivative of, then times the derivative, okay? So, I'll do an easier example up here. Let's say I do ln of x squared. That would equal to 1 over x squared times 2x. Okay? So does everyone see how that worked there? Ln of x squared, the derivative of that, changes to 1 over x squared times 2x. Now I'm going to show you how this helps me, Teresa. So what's the derivative of ln of y? What would that be then? Okay, you got to try here. The derivative of ln of x was 1 over x, so the derivative of ln of y is going to be 1 over y. Good. Now the only thing I'm going to add here is a dy by dx. Why did I have to put a dy over dx there? Derivative of y, right? That's what we said. Okay, so I'm going to pick a person at random, and that's going to be Derek Stanley. What's the derivative of ln of x to the 4 plus 1?
That would be 1 over 4x.
No.
Third, 1 over 4x.
Close.
Oh, yeah, 4x to the third over.
Yeah. Okay, so just so I didn't mean to humiliate you there in front of the class, that was an accident, okay? So the idea is it's going to be 1 over whatever's inside the brackets, and then times the derivative of that. I'm going to pick on another person at random. Austin. Can you take the derivative of 1/2, so just of ln of x plus 2? Go ahead.
I got 1 over 2 times x plus 2.
Whoa.
And then I multiplied in the...
Okay. Let's do it. Okay. So it's going to be 1/2 times 1 over x plus 2 times 1. I'll just do it expanded with that. And if you have an easier way to do it, then
Just get it all.
yeah. So the 1/2 stays as 1/2. Ln of x plus 2 changes to 1 over x plus 2. And then the derivative of x plus 2 is just 1. James, it's your time to shine. The derivative of ln of all of this is going to be what? Okay, no problem. I'm going to come back to you, so I want to make sure you can do this, James. No, not to single you out there. Nathan, you're raising your hand. Good. Go ahead.
1 over 2x squared.
Yeah.
That's 1
Yeah.
times 4x plus 2.
Now, isn't that nice? Like, isn't that really nice compared to what you've seen before? Now, what's the only thing that's different about this compared to every other equation that we've had when we took the derivative of? Like, what's the one thing that's sort of new and interesting and not existent in our previous derivatives? Okay, go ahead.
We never really have a bunch of different fractions.
Yeah, you never have a bunch of different fractions. Now, you could get a giant common denominator, and that's what you would do. If you were to take a derivative of the regular equation, you would have a giant common denominator, right? And that would work out. The thing that I was hoping, the dy over dx just means f prime. I was going to say this is the thing that's a little bit messy. Okay, is that 1 over y? Because we don't normally have that. So I'm just going to neaten this up. I'm just going to call, I'll do it in a different color. Dy over dx equals y, which is the original equation, times 4x cubed over x4 plus 1 plus 1 over 2x plus 4 minus 4x plus 2 over 2x squared plus 2x plus 1. Okay. Everyone see? Now, just be brave and ask if you didn't see how I got that. Brendan, how you feeling? We're okay? This is just algebra again here, right? If you remember, the first day of the year I gave you guys algebra and I said there'd be lots, but this is another example of just algebra. Michael, go ahead.
I don't get it. Right, it's not the same thing.
Oh, because, sorry, I just multiplied by y, right? This is like pretend this is like 1/3. To get rid of the fraction, you times it by 3, right, to bring it across. So I'm just doing the same thing as 1 over y, so I'm just multiplying by y. Now we're almost done. And you're rolling your eyes, and I can see you now.
No, I just
Front, you
don't,
can't
I don't
hide.
have this much space.
It's okay, we'll be able to get it done. What did the question actually ask us? It's low, okay? So I need 2 points, unfortunately. Because I have an x and I have a y. This is the only problem with this, is that you need your y value to get an answer to solve. Okay? So what I'm going to do, I was given at the beginning, if I can find my question. I was given, so x is equal to 1. That's what I was given. And y should equal this. Oops. Okay, so that, what I did is all I'm doing over here, Teresa, is I'm subbing one into my original equation. So I go that, right? I'm just subbing, you know, to get the y value. So my original equation, x to the 4 plus 1, x plus 2, all over 2x squared plus 2x plus 1. Does that look right to most people? That's a mess. What does that turn into? 2 root 3 all over 5. Is that right?
Want us to keep it like that?
Yeah, I'd leave it like that. Because this is just going to equal 2 root 3 over 5 times 1 half plus 1 sixth minus, oh boy, 6 over 5. So where I quickly got those numbers was I just subbed in 1 for my x's, and then whatever the final answer that happens to be. Michael, go ahead.
On the exam, we go back to the original way of doing this.
Yes. If I say to you, do this using quotient rule, I will. If I don't say you can do it the original way. On this test coming up, I will give you one that's messy like this, and I'll say, find the derivative using logarithms.
This one's definitely easier.
Well, it totally is. If you guys run your test, this is the question that people were crying about, and we're saying, this question is too hard. I don't need to solve this question. This is evil. If you don't think it was evil, that's okay. All right, but it was awful. This is to do this one by hand. To do this question by hand, Michael, would probably take you 20 minutes. And once you do a few of these, it just like go, 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 go. Like there's no hard thinking, right? Like it just all.
I feel like there's a lot to do.
Yeah, it is. And even test number 6, I think. No, 5. The one test number 5. Yeah, go ahead.
In the brackets, your first time, should it be 4 over 2 or
Stanley, and
Okay. Can somebody calculate that out for me? Because I made a mistake in my notes here, I think. Yeah, it would be. Can somebody just calculate all out for me and tell me what that equals? I can't do that in my head. I probably should be able to. 13. Yeah.
I got like the same answer. Like for the sum.
Yeah. 2 root 3 over 5. So this all
Oh,
equals.
and mine was something.
Yeah.
You want it in that?
Fraction, please.
That.
There's a fraction button on the calculator.
Well, I cleared it down. It's 29.
Like without
the 2. Oh, I broke it.
Over 150. I'll make these work out nicer, so that's 58 root 3 over 150, which is 29 root 3 over 75. I'll make it work out nicer on your test. I thought I did make it work out nicely, but I made a mistake. Okay? Now, forget about the slope for right now, Austin. Sorry, you're in my line of view, so you're going to be the person. Okay. I want to make sure the lawn part makes sense, okay? So the lawn, this is actually a tool to make your life easier. And whenever a student comes back to me and they say, yeah, let's see what work you're doing in class, I'll show them a choice assignment, they'll say, I just do this with logarithms now. I'm like, you're right, you would. Okay, so when you get to university, all these big ones, you still need to use your product and your quotient for like the small derivatives, but as far as the big ones, you can do it like this and get a whole lot easier. Okay, so if you're trying to find the rate of change of electrons on your phone one day, you know, you won't be doing it with a big equation like this, you'll be doing it with logarithms. Okay?
So is that finding dy dx?
That's finding dy dx, right? Because that's, or, you know, that's fine, that's the same thing, right? The slope. All right, I'm gonna hit pause. Is that time right?
yes, actually left.
Oh, no. Yeah, I gotta see what else I can give you for the last 20 minutes.
No.
Okay.